Hello everyone, am I audible? Hello everyone, am I audible? Uh, let's wait for 5-6 minutes. Let others join, then we can start. Um, for how many weeks assignment deadline is over? I think 3. Okay, yeah, this is over. Uh, the question pattern will be multiple choice questions only. Not the way which you get in assignments right now. There can be multiple select also, but mostly it will be multiple choice. True false as well, so you have to select either true or false like that. You won't have to type anything. Yeah, hopefully the question will be of 1 mark. Sorry, somebody saying something? Good evening, Praveen. So yeah, questions will be of 1 mark only. Um, Multiple select can be of 2 marks, but generally the tough questions are not made for say final exams, so there won't be questions with more than 1 mark mostly. There will be less than there'll be 1 mark only. I'm sorry, my internet. Every Friday, every Thursday, Friday, Saturday, Sunday, it's kind of wonky in hostels. So yeah, the questions will be on 1 mark only, mostly. There might be some, very few, like 2-3 questions of 2 marks each. I don't know about. You can email the professor and ask. But what I'm telling is from the past experience of NPTEL. Generally, the questions are not for more than 1 mark. Okay, yeah. It doesn't matter. The score is basically it's scaled normalized to 10 marks. Okay. There are nine questions only. There are nine questions only. Yeah. So some weeks you might get even 15 questions to solve. That doesn't matter because ultimately that will get scaled down to 10 marks only. So if you solve all 9 questions, you get 10 marks. If you solve, sorry, obviously, that's why you are given 2 weeks, I think, to solve it. Time like you can edit it till the deadline. So it's like giving you good evening. I will solve this week also. Great. What I can do is last time I shared as well. I shared solutions as well. If you go to this sheet, let me share my screen. Um, question 3 to 5 is not satisfying. Let me see. Is my screen visible? Okay. So yeah, week 3 doubt session. So you see, I have added week 1 and week 2 solutions here for last year's assignments. Okay. So please, after I upload the video, after you get the email or something, in announcements, please visit this section. Visit this Google Drive. Okay. You will find a lot of. See, if you go to resources now, if you open this file, you will find the books for machine learning I have added here. Okay. So it will be helpful to you guys. Anyways, how many people have joined? 17. So yeah, let's start. I think some new people have joined today. Satish is new, I think. Who has joined this session for the first time? Okay. So there are quite new faces here. I cannot see faces anyways. So yeah, do you want to discuss any doubts? Till now, whatever doubts you might have faced in courses, in assignments, any technical, conceptual doubt, whatever you want to discuss, then I'll start. Okay. So generally, I keep first hour for your doubts, solving your doubts, and the second hour, the 7 to 8 p.m. is for me, whatever I want to teach, or whatever you want to learn. It goes both ways. Okay. So I will discuss this Bala Sai. I will discuss this. SST is equal to SSC plus SSR. Okay, let's mark it because it's in week 4. The deadline is not over. I won't discuss it. I think deadline is over or not. Week 4. It's not over yet. I won't be discussing it to the solution level, but I will be discussing it. Sorry? Yeah, that's why I won't be discussing the solution. Saw it, just saw it. I can explain the questions 3 to 5 to 9. I'll discuss last year's questions first, and then I'll discuss whatever doubts you have. I will just explain the question to you for better clarity, and then you can solve it. Then first question in week 4. Okay. Week 4 first question. Okay, this deadline is not over. I'll discuss it. Just a second. Let me just ask any doubts, whatever doubts you might have in from week 1 to week 3. Okay. Praveen, can you mute yourself? I'm getting some weird noise from your end. Which question? Push. Okay. I'll discuss it. I'm noting down all the doubts which you are having. I'll discuss it once I start. Okay. So don't worry about that. Any other doubts from week 2 or week 1? Probability, matrix multiplication. Does anyone have any doubts? Okay, no problem. I'll do is I'll start with previous years. Or I can finish this week 3 assignment first. Okay, then we'll discuss previous years week 4. Yeah. I can do it, but it will be like very much out of scope for this course. I think so. It's a quite advanced topic. Yeah, I'll share some materials where you can study. Okay, I will note it down. Just a second. Okay, so I'll share some material. I cannot cover all, like these many things here. It's quite kind of restricted time. Weekly I get 2 hours only. Had it been like an hour a day, an extra hour or something. Anyways, I'll share. So do you want to understand? Sorry. Correct. Lagrangians are quite mostly used. For basically differentiation, where you don't want to, where differentiation is very difficult to compute. So in optimization problems, basically Lagrangians are used. This is the simplest explanation I can give about that. Apart from that, if you want to study maths, I'll share a slide, or there's a book. I'll share it. Just a second. Which one? Which video? Constraint optimization. Okay. I'll see. I'll let him. Just. So simply, this is done. Okay, just stay with me. I'll share the book. Actually, if you go to Bishop book now, it's even there. So so you have to basically optimize it given the constraints. So Lagrangian is what you call adding this original function to some this series, and then you optimize over it. So basically, Lagrangian and etc. are mostly used in dual form of SVM, I think. Yeah, to compute the dual form of SVM. People generally use this both the terms interchangeably, so it's not very hard and fast tool for us to understand, like for us to keep up with. But otherwise, I'm not sure actually. I too generally use Lagrangian. Okay, so yeah, just a second. So if you see this bishop, look, right? Something similar is being taught in SVM here. Yeah. So if you go through it, it's quite simple actually. These KKT conditions you have to optimize. Okay, so that's why I said I won't be able to teach it. It's quite of maths involved here, and that will become another class. It won't be just a doubt session then. So yeah, so if you go through it, yeah, chapter number 7 you will find. Okay. Okay, sure. Yeah. So let's discuss week 3, this week's assignment. Okay. Let me connect my iPad. Okay, so is this screen visible? Cool. So yeah, let's now start with week 3. Let me zoom this. So week 3 question 1 was while training a machine learning model using gradient descent, you observe that the cost oscillates up and down without clear convergence or divergence. Which of the following is adjustments to the learning rate is most appropriate? Okay, so you have some function here, cost function here. Okay, so it somehow it should not jump here. It jumps here, then it jumps here, then it jumps here. So this is happening because once you compute dou w by dou x, this is the slope, and you multiply some alpha here. So when this alpha is quite high, say it's our alpha is equal to 10, so the slope magnifies. So this learning rate basically is a lot. That's why it's jumping. So what I do is I'll increase this alpha to say 0.001 or something. I'll decrease this learning rate to 10 raised to power minus 3. In practice, for training models, while 10 raised to power minus 5, this range for fine tuning models. So this way the slope bumps like this. It might reach somewhere here and then comes back and ultimately it reaches the minimum. Okay? So decrease the learning rate slightly. The algorithm is likely oscillating due to a high learning rate. Any doubts in this question? Okay. Consider this function j w1 w2. You have to find critical points. Okay. So how do you compute critical points? So what you do is you compute its derivative with respect to w1 and with respect to w2. Okay. So if you compute its derivative with respect to w1, it becomes 6 w1 minus 12, and you equate it to 0. So critical point 1 will be 2, and critical point for w2 will be 4 w2 plus 10 equal to 0. That will be minus 5 by 2. Got it? Any doubts in this question? Okay. Cool. Let's move to question number 3. Evaluate whether the critical points obtained, what do they represent. So how do you compute if it's a local minimum, local maximum? I told in last class, remember? The people who were present there. For? Yes. If both are greater than 0, it's a local minima, right? Are you sure? Somebody explain it for me. Yes. Correct. Both are greater than 0, and HCM, what is the HCM of this matrix? Correct. Is it the same question given last year? It's almost the same question. Actually, no, almost, not exactly. Different. Actually, derivative also, determinant is also 24 for last year. Okay, so, that's, since all three are greater than 0, it becomes a local minimum. This you can compute. It's mathematical question, you can write code for it. Question 4. Okay. And also in question 4, okay. For same function above, assume the gradient starts from 0, 0, but with learning rate 0.2. Find the values of w1, w2, which learning rate becomes. So obviously the 0.2 will bring it closer to minimum faster because the learning rate is higher. Okay. Than 0.1. This is the general intuition. Otherwise, you can compute the code which you have written for computing this question, these w1, w2. For question 4, basically, I don't think so you are able to see my screen. So similarly, you will have to compute for 0.2, and that will become derivative. That will become learning rate, and then you can find out the loss. Okay, so generally this when the learning rate increases, the points moves faster towards minimum. Okay. Question number 6. Again, these are the similar kind of question. I can I won't be solving it manually because they cannot be solved manually easily. I have to do a lot of computation here. So someone has written question 5 to 9. So Surya Sai, I have discussed this type of questions in last week's video. So they were solved using computer Python or MATLAB programming. You can solve it, or you can compute the derivative manually and place the values and solve it. Okay. So if you want, actually I will share this last week's week 3 slides as well. I'm adding in the Google Drive link right now. Okay. So this way, what you will be able to. Yes, you have to derive it and solve it. I don't think, yeah, with the virtual calculator you have to solve it. So just assume, not assume, just learn to solve derivatives for simple equations such as this. This is a cost function. This is a basically mean square error. Okay. So just learn, just basically solve these types of questions with mean square error, and you will be able to solve it in exam. Okay. You don't have to worry about solving very higher order loss functions, derivatives, etc., etc. So same question number 7, 8, 9. They are like similar questions. You just have to solve it manually, put the values. Try solving it. If you're not able to solve it, write code for it. Now I have shared. If you open this doubt session Excel sheet and Google Drive, I have added last year's week 3 assignment solution here. So week 3 had these types of questions. The solutions are there. You can just go through them and solve it. Okay. Any doubts till now? Okay. So last question is simple. What is the purpose of generalized Lagrangian function in constraint optimization? So basically it converts the problem from constraint optimization to unconstrained one by basically placing the constraints into the objective function. So this might also have been taught in video. So you don't want to maximize the number of constraints, calculate the exact value, you cannot compute it, eliminate the need. Yeah, we eliminate the need for constraints, but it actually does not work in that way. So the answer is B1, to transform a constraint optimization problem into an unconstrained one. Okay, any doubts till now? Okay, what I can do is I can take a session today to basically write code for solving machine learning, like derivatives, etc., etc. Okay. So from 7 p.m. I'll start. Till that time, we'll just finish up assignments. Cool. Any doubts in week 3? Please don't ask me to solve these questions. Like I cannot do it manually. It's very time consuming. So what I can do is I can show you how to write code to solve it. Okay. Any other doubts in week 3? Okay, I don't think so. People have doubts. Let's move to last year's week 4. Okay. So the problem is I cannot share my what do you call? I cannot share my system screen and iPad screen simultaneously. So what I will do is I will open the solutions. Okay. Let's go to last year, week 4. Is it visible? Hello? Okay, so these are week 4 questions for last year. I think you might have got similar questions this year as well. Okay. When I try to open the solutions, I'm not able to open the solution, so I'll have to solve it. Okay, yeah, these are week. I thought I opened something else. Additional materials, I think I opened. So, any one of you, can you read out question number 1? Unmute yourself, read it. So yes, there are 2-3 types of gradient descent methods. The most common one is batch gradient descent or normal gradient descent. In that method, you take the whole data set, you compute forward pass for all the points at once, and then you take derivative, and then you compute backward pass. But what happens is your system memory is not that much big to compute gradients and forward passes for whole data set at once. So then what you do is you take mini batches of data, you split your data in some small batches, and then you start computing the gradient. And after you compute the gradient, you compute the forward pass for one batch, and then you go back and compute the backward pass, and you do it again. So basically what you do is you make the data split in multiple batches. In that way it sort of becomes like one data, multiple datas, and you basically train it on multiple data sets. Then stochastic gradient descent is when you compute parameter update, which means forward pass and backward pass for each training sample. This brings a lot of noise in training, because it does not accumulate the loss or properly for all samples. So the basically loss very for one training sample, loss is at very high value, for another one it's very low value. So it's not able to optimize the model very efficiently. So that's why we take the middle ground, and we generally prefer mini batch gradient descent over batch gradient descent and stochastic. But anyways, the answer is stochastic gradient descent. Coefficient of determination, what is it? Is the proportion of dependent variables variance explained by independent variable. Okay, it's nothing else. So this is given to you. What is RMSE? Can anyone open the calculator and compute? Well, let me compute it. So RMSE is root mean square error. So what I do is say minus 123 plus 114 is 9. 0.5 122 minus 86 is 36. Okay, and that is 30. So 9 square is 81. Okay, plus 0.5 square is 0.25, plus what was this value? $36 or $38? $36. 122 minus 86 is 36. 36 into 36 is 1296. So 1296 plus 900 plus 0.25 plus 81 is 2277.25. SQRT 2277.25. I did some mistake. What mistake did I make? Screen is not visible? Oh, I should have said earlier. Visible now? So yeah, what is root mean square error? We take the difference, okay? We compute square, we add, then we take root. Correct? So am I audible? So what is this? This is the difference is 123 minus 114 is 18. Oh sorry, my bad. So 18 square is 324. 324.5. Then this is 36 into 36. 1296. What was 18 square? 324. 324 plus 1296 plus 0.25 plus 50 and 10, that's 100. 1720.25. 1720.25. We compute square root. 41.47. Am I doing something wrong? Oh, sorry. I think this spotlight thing is not coming to the screen. No problem. Let me open calculator. Calculator is visible, right? This calculator is not visible to you. Okay, anyway, somebody solve it for me. I'm giving the values here. Take a pen, paper, solve it. Tell me what's the answer. Or you can solve it yourself. The questions are very simple, right? This thing you can solve. Just copy the values, okay? Solve it later on. Okay? Let's move to next question. After this, what is R square? Let's leave it. You are examining the relationship between employee salary and two independent variables, years of experience and number of certification courses completed. You use linear regression and obtain the following equation. For every addition, which of the statement is true? So for every additional certification course completed, the employee salary increases by 2500. So say initially I have this thing 0. Okay, x2 is 0. Sorry, number of experience is 0. So the employee with 0 years of experience and 0 certification will have salary 6000, correct? Because this will become 0, this will become 0. But if I take some certification course, for one certification I'll get 1500, for other one I'll get 3000. So it won't increase by 2500, it will increase by 1500. Okay. Just a second. Okay, just a second. I need to send in. Okay, sorry about that. I have to send an urgent email. Are you guys here? Okay. The influence of years of experience is stronger than influence of certification courses. Yeah, it should be correct. It should be correct, right? Am I audible? This option 3 should also be correct for this one. Because if you increase both by 1, the salaries influences experience experiences influence is higher on salary than certification courses. So I think this one is also correct with 2 years and 3 certification courses. With 2 years and 3 certification courses, you can compute it, but I think this option is correct along with this option, along with this option. I don't know, like this question is vague. I mean, the effect of stronger is not clearly stated here. I mean, I can do 3 courses per year, but I cannot increase my experience by 3 years by working 1 year, correct? So that might be the case. So this language is very vague, and this language is quantitatively correct. So I think that's why this should be the correct option for you, correct choice for you. Yeah, that can also be the case, but he said that if it's not given, in that case we have to just go with the best option. So best option is the most quantitatively correct option. For the second, okay, same problem. You can compute it. It's very simple, like 3,000, 2,500 to 1,500, 1 unit increase. This will increase it by 4,000, correct. Yeah. Can anyone read this question out for me? Question number 7. Okay. Okay. So since the answer is visible to you, can anyone explain me why the answer is B, not C? Anyone? Okay. So once you increase the model complexity, Okay, so what is high bias? My model is very highly biased, which means that whatever input I give, okay, it will give me the same output. This is very highly biased model. So say I take a function y is equals to 2, fx is equals to 2. So whatever value of x I give, it will always give me 2. This function I will call highly biased function. Okay. And what is very high variance model? So high variance model is the model which is basically for which if I change the value a little bit, the answer changes drastically. Okay. So when does the problem of high variance occurs? So assume that I have to teach a course and I want to give grades to 80 students, and I gave marks to students very leniently, and now the range of marks is very less in this much, and now I have to basically award them grades. Okay, so what I'll do is if I say I'll start awarding the person who scored 95, I award him A. The person who scored 93.5, I award him B. Okay, so this means the grade has changed drastically with this 1.5 mark. So this distribution, if some sort of model is behaving like this, okay, so that model we generally call it as highly high variance model. So we don't want these two things in our model. Okay, so we have to find the balance between underfitting and overfitting. So we are overfitting in case of high variance and underfitting in case of high bias. Yeah, so anyways, so that's why this option is correct. High bias models are too flexible and can't fit the noise. So they can fit the noise, but they are not flexible. Anyways, like they are giving literally the same output for a lot of variety of data. So I won't call them flexible. That's why this option is incorrect. They can fit the noise, correct. If I say if I pass 0.2 and 2.2 and 2.25, the answer should be roughly same. For high variance model, it should not be same. So they can fit the noise, that much noise, but they are not flexible. Okay, so that's why option B is only correct option. Again, you have to compute the whole gradient descent thing and compute the error after 3 iterations. Okay, so for each sample, there we have 5 samples. You have to compute the error. So I will share it. Okay. What is the value of weights after 3 iterations? These all things we'll solve while coding. Okay, so now read this question. Question number 10. Anyone? So can anyone tell me which one of these 3 graphs has basically captured the noise? Basically, it has overfitted on training data. Basically, a high variance model. See how I connected these 3 terms. Captured the noise. Okay. Now it has become overfitted model, and now it will give me a high variance output. So since trained data is visible to the model all the time, so training loss will be low than validation loss all the time. Mostly, if it's high training loss and the validation loss is low, this means you have done something wrong while setting the training. But mostly it's like this. Okay, the training loss is very low compared to validation loss. Training loss is very low compared to validation loss. Now you have to see where the difference is very high. The difference is very high in this case. This means that validation loss has not reduced. This means it's overfitting the training data a lot. So once it starts overfitting the training data, it means that it has captured the noise in training data. It has started to overfit, it has introduced the complexities, the polynomial complexities in the model. So the graph 1 should be the correct answer. Because since it has overfitted the training data, it cannot generalize over any new data. It will always give very poor outputs. So this means that graph 1 is the correct answer. Got it? Cool. So any doubts till now? No doubts? Okay, so anyways, these were the discussions about week 3 and week 4, last year and this year. Okay, so let's take a 5 minutes break. I'm not well today, actually, a throat infection. So let's take a 5 minutes break, and then we'll just resume with the coding session. Okay. says wait for 2 more minutes and then we'll start. I have to exert a lot today because of throat infection. Okay, so yeah, let's start. People have left. Those who have left, I can. Let's wait for 2 more minutes. I think people who have taken breaks, they can join. Am I audible? Hello? Cool. Okay, so what I did was I took these values which were written here. Okay, sorry, and I basically wrote code for this directly. Okay, let me just copy this just to be clear. Okay. So this is the whole image, binary encoded image, which is rendered here. So this thing also works in Google Colab. So let me just show you. So you have been given 3 variables, x1, x2, x3, and correspondingly 3 weights, theta 1, theta 2, theta 3, and theta 0 is bias. So what you do is theta 1 into x1, theta 2 into x2, theta 3 into x3, plus theta 0 bias. Okay, this is the this is the hypothesis. This theta 0 to theta 3x3 is hypothesis. This y is the given output. This whole thing is loss function. So yeah, let me show you here. If I do this, this is how you get the rendered image. Okay, so what I've done is generally in machine learning, generally in Python, when we do machine learning, we use these 2-3 libraries, NumPy, pandas. Okay, so I won't teach you this right now because it will be then out of scope. I won't be out of scope, it will take a lot of time. I'll keep another session to teach NumPy pandas. Actually, I taught Python in, I think, session 2, week 2 doubt solving session. Okay, so let me just do it. Just assume that you know this thing, okay? Just assume, and then I'll tell you how to do it. So basically, you take this matrix, this data matrix from x1 to x3, and you write it in this form. Then you take the target values or labels, you write in this form. So it becomes 3 cross 4 matrix, and this becomes 1 cross 3 matrix. And this actually becomes a vector, okay? So number of training examples are length of y is 1, 2, 3, 4, 4. Okay, so m becomes the, because we divide by 2m, right? That's why we need m. We need to sum over it and we divide by 2m, okay? So anyways, now this loss function, why do we write 2m here? Can you even tell me? And just not m. You have to basically do the average over the summation. Why do we write 2m? Anyone? Yeah. Still, why not 2? Why 2? Why not 3? Why not 4? Okay, so let me tell you why 2. So what happens is, how many of you know differentiation? I think all of you know differentiation. When you compute derivative of this thing, what is the derivative? Derivative becomes 2 times this whole thing, then inside this whole thing derivatives. So you see now this extra 2 comes here. So if you take this gradient, this whole slope with extra 2, the slope will be very high and it can start oscillating, right? That's why we remove this 2 by dividing it, and it becomes unnecessary because it's a scalar value. It doesn't change the slope, basically affects the slope by a lot, but it doesn't affect the computation. So that's why we divided by 2, so that this 2 goes away. Had it been a cubic function, we would have divided by 3. But problem with cubic function is that the cubic function is not positive. Okay, it becomes negative. It has a point of inflection, and it has a saddle point. Yeah, it goes like this or this, something like this. So that thing also affects the output. Actually, cubic function is like this. It has a minima and a maxima both. So that's why it's not preferred to use cubic function or quadratic power 4 functions, because those functions have multiple maxima minima, and in machine learning we don't want this to happen. But in deep learning it happens a lot. Multiple maxima minima are there, and then we have to find the global maxima, global minima. So for that there are different techniques. Anyways, for this thing that's why we divided by 2. It doesn't matter if we divided by 2 or not, but general convention, mathematically it should be. So yeah. So alpha given here was 0.1, right? It's 0.1. Let me change the learning rate to 0.1. Okay, so what I'll do is, I have a bias also. This X bias is there. Okay. So what I can do is, if I want to add a bias, I can add a column of 1 here. Does it affect the output? If I add just a linear feature, simple constant feature, and if I multiply theta 0 into x0, theta 1 into x1, theta 2 into x2, so x0 is already 1, all values are 1, okay? And now thetas are 0, 1, 2, 3, 4, correct? Any confusion? Let me do it one by one. Any confusion till now? Okay, let me just run this code. Okay, let me remove this value. I'll show you why I added this. Let me remove this. Somebody put up something. I will share this Python program which I'm doing. Okay, and I have already uploaded the last year's victory solution in Google Drive, so you can find it there. So yeah, if I just do this, and if I take this y here, okay, oh sorry, now is it visible? So if I print x, what is x? X will be a matrix, 3 cross 4 matrix, like this, and what will be y? Y will be a 1 cross 4 vector. What is m? M is the length of y, which is 4. These are iterations. So in machine learning, deep learning, there is no sense of iteration. This is basically a stopping criteria for computer. Otherwise, if you ask a computer to stop after some loss, so you have to either define that loss or you have to stop after some iterations, because it cannot determine when to stop. Okay, so if I see, it's also doing the same thing. X bias is basically adding 1 to this matrix. So this matrix X bias becomes original matrix with a column 1, column of 1 in the start. See, it was 1 2 1 1 2 2 1 3. Now it becomes 1 1 1 2 1 1 2 1 3, right? So this has basically taken a 4 cross 1. NumPy 1 basically gives you, if I show you what does NumPy 1 do, NumPy 1 basically gives you a vector of 4 cross 1. So it will be a column, so a column vector of 4 cross 1. Then what you do is you concatenate NumPy and concatenate, you concatenate this 4 cross 1 vector, plus you basically stitch them together. So this becomes this. So what I did here was the same thing done here. So this adds a bias feature to matrix. Why do we add it? Because theta 0 plus theta 1 into x1 looks fine, but problem is if you write the matrix in this way. So theta has 4 features. Theta has 4 features, 4 weights, 4 weights, while x has 3 features. It cannot be multiplied. Therefore, what we do? We add constant feature. Got it? Sorry? No. Bias is simply a term. See, what is the purpose of bias? In machine learning, bias basically takes some inherent property, inherent weights, and bias basically y is equal to mx plus c. Ultimately, you have to get this equation for a linear function. Okay? So if I just compute m and not c, it will always start from origin. Bias gives you some starting point. When the slope is 0, everything is 0, it should start from somewhere. The intercept, okay, the y-intercept. Bias is that term in machine learning, if you want to understand it mathematically. So if I give you some x, y values and I ask you to compute y is equal to mx, okay, and you can compute it, but then I ask you how are you so sure that it starts from origin? Because there is no c term added. So even if c is 0, you have to compute it. Otherwise, what happens is the loss might not decrease that much. Okay. So if a function starts from origin, if a function does not start from origin, but you fit a line starting from origin, ultimately it will start creating higher losses later on. So that's why you add a bias to basically negotiate for that. Okay. So after adding bias, this becomes this. Now let me do. So let me do it for 3 iterations. Okay. So what then? What we have to do? We have to basically perform h theta. Just a second. H theta. H theta is, what is h theta? It's theta into x. Okay. Then what is loss is h theta minus y. Okay. Then gradient is derivative of loss. Then change in theta is theta old minus grad into learn rate or alpha. This is the algorithm. This is the pseudo code for the this is the pseudo code for this whole thing. So let's compute it. So let's compute it for 3 iterations. We were asked to compute after first iteration of gradient descent what are the values of theta. Okay, let's compute it. So for I is equal to range in 1 for one iteration. So what does x bias dot theta give us? Let's check it once. Okay, it's giving me 0. Why? Because the thetas are 0 right now. If I print theta, I've printed theta right, not printed. Theta is 0. So shape of theta's shape is 1 cross 4, while x bias shape is, or simply x shape is some 3 cross say 200 something. Let's write it like this, because the training samples right now that we have training samples 4. So if I write 3 cross 4, you might get confused that this 4 and this 4 should be multiplied. Okay, so this should not be the case. So let's assume it has some these many samples here. Okay, so now you cannot multiply it. You cannot multiply theta into x, right? The problem will become you don't have common features. So that's why you add bias here. Bias plus 3. Okay, so it becomes something 4 cross something. Okay, so the multiplication can be done in this way. So it can be done in theta into x. Okay, or x transpose into theta. Anyways, both of the ways are possible. Okay, so ultimately what you should get is you should get a 1 cross 4 output for all features. Okay, for all features you should get, or wait, no, for all x, let me increase one value here. 1 2 3, that way you can understand it better. So now the shape is 5. Okay, now if I compute x bias, okay, so let me compute this. Then y label should be 20, 20, 40. Let me add this here. And now m should be 5. So now y5. So now it's fine. Okay, now if I compute x bias in dot theta, now it's giving me 5. Correct. Okay, so yeah, so output is always 1 cross number of samples. Correct. So let me just go back. Am I audible? So let me go to the original data. So we have x, we have y, we have m. Okay, so this thing, let me delete this. Or let me just keep it written like this. Okay, you add x bias becomes this here. So what you get is this output. This gives you 1 into m. M is the length of y, length of whole data. Okay, so that's why you are able to subtract predictions. This predictions become this. Then if I subtract y from here, minus y, you again get a zero vector, say some negative vector. Okay, correct? Got it? Yeah, that's why I'm just telling you the concept. Okay, so code you can, like, it's difficult for first time learner, it's difficult for you to understand, but see, I take predictions give me this shape, 1 into number of samples, and this also gives me this shape, 1 into number of samples. Okay, so if I compute it for, say, let me just comment out these two lines. Okay, now what I do is I compute the gradient. So this is error is giving me loss. So problem with this loss is just some difference. What I have to do is I have to compute, what do you call it, root mean square error. Okay, so what I can do is compute RMSE error for RMSE error for gradient descent. Actually, this thing helps a lot. You don't have to write a code. This Gemini thing helps a lot. Okay, so if I don't compute it in this manner, now this whole derivative thing, this will create a lot of problem. The answer might not be the same. So if you see here, they have taken gradient manually instead of taking like this. Okay, so let's do it manually. Okay, so now we have some errors here. What is the error function? So what is the derivative with respect to theta? Derivative with respect to theta is this whole loss derivative. Let's do it this way. The way in which this is written. Okay. So what I'll do is I'll compute gradient and theta. So I will print gradient comma theta. I'll run it for say 10 epochs. Okay. So as you can see, as you can see, the gradient initially the gradient is very high. Why? Because the initial weights are 0, and so it computes the slope. Slope is computed here. So if you compute slope of simple this gradient, okay. So if I remove this thing 2 part here, so it becomes 1 by m. Derivative of this becomes only the summation, only these errors. Okay. So we multiply this transpose dot errors, and we take the gradient and we subtract the gradient by learning rate. So our see, initially after first iteration my weights change, then they start decreasing, increasing, decreasing, fluctuating. Okay, see, this becomes 3 point, then 1 point, then 2, then 2, then 2, then 2, then 2. Okay, so these how the weights are become right at the last. Okay, so let it compute for say 20 epochs. So finally we have these weights. See, these have started saturating over 2 point around this. Okay, so now what I'll do is say if I compute the final, so y is equals to x bias dot theta. It's 6, 10, 13, 18. Okay, the y we had was 7, 10, 12, 20. So see, we have come very close to this, right? So let me do it for some more epochs. Say I'll do it for say 50 epochs, and now let's compute y hat. Y hat, let's print both of them. Okay, so see, this value has stopped decreasing, this weight has started becoming negative. Okay, so this is how the gradients are changing. So ultimately you are getting closer. That last time it was 18, now it's 19, it was 12, 13, this is very high still, this is very close, this is very close. Okay, so if I say do it for another say 100 epochs or something, can we get closer? Okay, so now y hat, let's see what does it become. 6.88, this has become constant, this has become constant, this has become, everything has become constant now. Okay, so ultimately say after 50 epochs, it doesn't matter how much I extend it, the weights are not changing because the slope is not changing. So what I can, why is it happening? Because we have already found the local minima. We have already found the local minima for this loss. Okay, for this loss we have already found the local minima and we cannot go any down. Let's change the learning rate. Let's change the learning rate. Say to 0.5. Now let's see what happens. See, the weights have fluctuated a lot. This has gone to very negative. Okay, now let's compute. This is original. Oh sorry, I didn't compute for last case. See, it has fluctuated a lot because it has happened because the learning rate is very high. Okay, so that's why learning rate, you should always try to keep it low. If I change to 0.1 and then compute, so see, this become ultimately 0.1 is the appropriate learning rate for this problem. Okay, so this is how you compute these things. Apart from that, like this code has given, okay, so we can also do it this way. Okay, so let me tell you how. What is the derivative with respect to theta 0? Remove this summation, etc., etc. Just take this part. What is the derivative of this part with respect to theta 0? No, 2 times loss into 1. 2 times this thing into 1. Okay, with theta 1, what is the derivative with respect to theta 1? 2 times loss into x1, correct? With theta 2, 2 times loss with x2. So ultimately what you can write here is, let me do it manually. Okay, let's not do it this way. Let the loss be computed this manner. Okay, so let error be computed in this manner. So I will write grad theta 0 is equals to 2 times error, okay, into 1, correct? No, it should be total error. Chain rule. In chain rule, you apply chain rule over here, right? Okay. Now this will become x1. So x1 is x bias of colon comma 1. It should give me this thing. Let me check. It should give me 1, 2, 3, 4. Yeah. Similarly, for theta 2, we compute. So you can also write like this: x bias colon comma 0, 1, 2. Okay. Then we take grad theta 3 is equals to 2 times error. Okay, 3. We compute the gradient. How this is the gradient. This is the gradient with respect to each weight. Okay. So let me write this way. The way which you can understand, let me write in this way. Theta 0 is equals to 0.0. Theta 1 is equals to 0.0. Theta 2 is equals to, theta 3 is equals to 0.0. Okay. Got it? Okay. Now what I'll do is I will compute prediction. So prediction will be theta 0 into theta 1 in, I am stitching these rows, okay, like this way. Got it? These are the predictions. I will remove this line for your better understanding. Error will be this thing, gradient will be this thing, okay. Theta 0 will be theta 0 will be theta 0 minus alpha times grad theta 0. Okay, so if weights are less, you can write the code like this way: theta 1, theta 2, theta 3, theta 1, theta 2, theta 3. It should give me some error initially. Theta 0 is not defined because I haven't run this code here. What I have to compute? We have to compute theta 0, theta 1, okay? So let me print theta 0, theta 1, theta 2, theta 3. Okay, let me run it for 1 epoch. I have run it for 100 epochs. 1, 1.6, 2.2. Oh, okay, why is it printing so many values? Let me do it manually, check what's the error. Okay, this whole thing minus y. Okay. What is grad theta 0? Okay, it's for all the samples. Okay, so we have to sum it. We have to perform summation. Okay, because it is for 4 samples, right? The error should be summed for 4 samples. Getting my point? The error is summation over this thing. So even if I compute this whole gradient, it should be summed together. So this should be numpy dot let me take it average. Okay, let me remove this 2 because this 2 will get divided by computing average. Numpy dot it should be one of this function. Okay. How they have done it? They have taken x, y, 0, 0. Okay, that way you can also do. Or yeah, we are doing similarly. Just some what do you call logical error. We are making some logical error here. We are taking 4 samples. If I compute average, what would be the average? This is the average. Grad theta 0 should be a single value. Then theta 0 should be again a single value. Why is it 4 values? Alpha, what is alpha? Oh, I have to start from here because I didn't initialize these values for this code. That's why it's giving this error. Yeah, so it's 1.225, 3.5, 2.5, 2.4. You can check 1.225, 3.5, 2.5, 2.4. This is the correct answer. See. Got it? It took a lot of time, but it was worth it. Right? Was it worth it? I have given this code as well which computes it, but the problem with this thing, it's not taking the square of this thing and the loss which is being computed here. It's actually fine. See, what we have done also the same thing. We multiplied the bias term, but this you might not be able to understand it properly. We also did the same thing. We multiplied error with bias, then we took the average dividing by m. Okay, we took the average by multiplying error by 1, but we did it for all weights separately. Okay, so this might be more interpretable for you guys. Okay, so next question, what is the cost value after first iteration with gradient 0.1? So cost value is loss. Okay, so what is lost after first iteration? After first iteration, after completion of first iteration. Cost value after the first iteration of gradient descent. Let's compute it. Let me print error. Print errors. Okay, this error is this. Let's do it first. After first iteration, the error should be this thing. 7, 7, 14, 14 and 13 is, it should be 27 or something, 26. 7.9 plus 7.4 plus 8.1 plus 5.125 is 28.525. Anyways, that might be some issue with the logic which we have done, but 28 and 26 are quite close to it. Okay. So you got it? Any doubts till now? I have already uploaded it. If you go to this, I'm not sure I can share it. Like I only after the deadline is over only I can share it. I don't know, but I don't know if I can share it or not. Yeah, previous one only. Okay, I'll share it. Okay. So yeah, this is sufficient. Got it? This is sufficient, right? to compute the loss. So the error should be prediction minus this whole square. So let me make it numpy dot power comma 2. What is power? It's power. I don't know. Oh, shit. Okay, so since we have not taken derivative, let me just print it on this. This is wrong. I mean, the way of writing is wrong here. Let's just print the square error. So yeah, as you can see, the error square to the power becomes, it reduces after each epoch, and if I change it to say 10 epochs or something, let's not print theta for now. Let's see the error against each sample. 49 to 26 to 2 to 3, again it oscillated a bit for all samples almost. It reduced, increases, reduces, increases, okay. But from 144 we went to 1, say. For 400, from 400 we went to 1. So this is quite good. Okay, so yeah, this will be all, and this is week 4 CS49. I think that will be all for today. Any doubts in this? Mm-hmm. Let me just read the question. Actually, I'm not sure. Let me read it. SR would be something by something. Temperatures, the volumetric heat, thermal conductivity. If you fit a linear model between x and t, suppose the optimum values. Was it not taught in the videos? SRST. I think that was taught in videos, right? SRST. Let me check. This is R is sum of square and sum of SR and STS, SSC and SST. Okay. This thing. Yeah. Let me write it here. This SSR and SST is this thing. SR is basically your SSC. ST is basically your SST. This is sum of residual errors. SSR, sorry. This will be SSR. Sum of residual sum of errors. Square sum of residuals. SSR, SST. You might have been taught this computing this error R square, etc., etc. Which one this, I think this one, goodness of it one. this video you might have been taught. Let me show you. See, this R square is being taught here. R square. See, this is SST is ST, okay? This SSE is your SSE. SSR should also be there. This SSR is your SR, okay? This is what yeah. That I think that is one miscommunication type of thing, but that's why weekly doubt sessions are here. So yeah, so these are the kind of doubts I can address in assignments, but I cannot solve it till the deadline is over. So yeah, this one is also solved. Any other doubts? Yep. You can just open this sheet. You might have been shared on email or announcement, and you can open this doubt session directory here. And you will be able to find it. Let me upload week 4 as well. Okay, so any other doubts? I will upload this video soon, tonight only. I don't have to do anything like generally it happens. I have to stitch videos and etc. When I take this recording stops somehow, but today it went really nice. So I'll upload it directly, and in an hour or so you can access this video as well. So I think yeah, that would be the end of session. If you have any doubts, let's just stay for 2 more minutes. If you have any doubts, you can ask me. You're welcome. Let me upload this as well. Okay, so notebook also, this also notebook has been uploaded. So you can directly open these notebooks on your collab. You don't have to worry about installing anything. Okay. So yeah, let's end this session for today. We'll join next week. That will be week 5. I think for week 6 or 7 I have to schedule it on some other day because I have to go for a conference. Let me just check my calendar. So I will inform you beforehand, 2 weeks ago before that. In March 14th session, that holy one, I will not be able to take on Friday. That session I can take it on Saturday. Yeah, that session, or I can take it on Tuesday, 18th of March. Okay, so I will email NPTEL team and you will be informed in beforehand about that. So yeah, that will be all. Thanks a lot, guys. See you next week. Bye bye, take care.